Okay, so let's continue with problem number 6. Okay. So looking at the given, y is equal to the logarithm of sine of x squared to base 7. So obviously this takes the form y is equal to the logarithm of u to base a. Okay, and what did we say for y prime? Y prime is simply 1 over u times the natural logarithm of a times du. Okay? Okay. So here, in this problem, our u is sine of x squared. And our base is 7. So applying your trigonometric differentiation, sine of x squared, the derivative of sine of x squared is cosine of x squared times derivative of x squared is 2x. Okay? Or du is equal to 2x cosine of x squared. Okay, so applying this rule, y prime is equal to, so going back now to the original function and differentiating the original function, y prime is equal to 1 over u, which is sine x squared, times the natural logarithm of the base, which is 7, times, okay, so we're done with this portion, 1 over u ln of a, times du, okay, times du, which is this, 2x cosine x squared. So times 2x cosine of x squared. Now we can simplify further as y prime is equal to, okay, 2x cosine x squared over sine x squared, the natural times the natural logarithm of 7. However, okay, you know that cosine x squared over sine x squared is cotangent. So finally, you can express your final answer, or the answer rather, as y prime equals 2x cotangent x squared over the natural logarithm of 7. 2x cotangent of x squared all over the natural logarithm of 7. Okay? Next problem. What about y? Okay, this is now problem number 7. So number 7, how about y is equal to tangent of x raised to x? Okay, how shall we solve this? You might say, okay, it's in the exponential form because the exponent is x. However, the base is not a constant. Okay? How different is this from our exponential functions? Your exponential functions are, take note, y, okay? Y is equal to e raised to x. E is a constant. y equal to a raised to x. A is a constant. It's a real number. Okay? But for number 7, tangent x is raised to x. Okay? So our target is, our goal is to bring this down. Bring down the exponent x. So how shall we do that? So before differentiating, we will, okay, get the natural logarithm of both sides. Okay, so take the logarithm of both sides. Okay, we take the logarithm of both sides. So logarithm of y, the natural logarithm, may we use natural logarithm, ln? Okay, so ln of y is equal to the natural logarithm of tangent x raised to x. Okay, again, recall from your, okay, log of b raised to n to base a, this is equal to n logarithm of b to base a. So, if we apply that here, what happens to x squared? Okay, what happens to x squared? We can write this now as the natural logarithm of y is equal to x, okay, x times the natural logarithm of tangent x. Okay, and now apply implicit differentiation to find y prime or dy over dx. Okay, so by implicit differentiation, derivative of ln of y, the natural logarithm of y, is 1 over y times dy over dx. Okay? Or y prime, or whichever symbol you'd like to represent the derivative. You can use y prime or dy over dx. Equals. Looking at the right side of the equation, we have a product. Okay? X times ln of tan x. X times the natural logarithm of tangent x. Take note that this is, okay? We have to enclose it in a pair of parentheses. So, u times v, okay? U times v has the derivative u dv plus v du. So, u is x times derivative of the natural logarithm of tan x is 1 over tangent x, 1 over u times du. Derivative of tangent x is secant squared x. Okay, but we're not done yet. This is only u times v. Okay, u times v plus v du. The second factor, natural logarithm of tangent x times derivative of the first, which is 1. Okay, so 1, or we could now, since we only want dy over dx, we can now multiply the whole equation by, y to get rid of this. We will multiply it by y, so this one will now be eliminated, leaving dy over dx on the left side is equal to Okay? Multiplying this with this or applying distributive property will end up with xy secant squared x over tangent x. I hope you can follow. Where did I get xy? That's after multiplying. Okay, after multiplying y to each term inside. Okay, so y times x, okay, times secant squared over tan x plus, okay, plus y times the natural logarithm of tangent x. Okay? You may leave your answer this way or express it into, okay, express this into a single fraction as this is all right, but you can express this in a single fraction as y is equal to dy over dx is equal to, may we have the continuation here, dy over dx is equal to, let's copy from the previous, x y secant squared x, xy secant squared x, okay, plus plus y tangent x, natural logarithm of tangent x, all over, let's go back, all over tangent x, over tangent x. Okay, so that's it. Or you can leave it this way, you leave your answer in this manner, it's okay. This is all right. Okay, this is already correct. This is all right. Last. Okay, problem number 8. How about f of x is equal to 8 raised to x minus the logarithm of x squared plus 1 base 5. Okay? F of x is equal to 8 raised to x minus the logarithm of x squared plus 1 to base 5. Okay? So let's differentiate the first term. The first term is exponential in form, a to the u, or a to the x rather. So its derivative is simply 8 raised to x times the natural logarithm of 8. Minus, the second takes the form logarithm of u to base a. So its derivative will simply be 1 over, okay, x squared plus 1 times the natural logarithm of 5 times the derivative, which is 2x. And that's it. Okay? So f prime of x is simply 8 raised to x, natural logarithm of 8, minus 2x all over the quantity x squared plus 1 times the natural logarithm of 5. And that's it. You may end up here. Or should you wish to put them together, then f prime of x is equal to 8 raised to x, natural logarithm of 8, times x squared plus 1, natural logarithm of 5, minus 2x, all over x squared plus 1, natural logarithm of 5. Okay? So for your assignment, you are to find assignment. Number 1, find dy over dx if y is equal to sine x raised to tangent x. And number 2, find y prime if y is equal to Okay, so please take note of your assignments. So these 2 items will be for assignment. Okay, number 1, find dy over dx if y is equal to sine of x raised to tangent x. And number 2, find y prime if y is equal to secant of 3 raised to logarithm of x squared base 2. Okay, so we will end up with this. So by next meeting, we will begin with the applications. And then the week after that, integration or integrals. Okay.